in ecology, so we're talking about living and non-living factors in an ecosystem is what we're going to work with today. Identifying them, we're going to put together a list of them here. Then I've got some homework to check off for you guys. You're supposed to have page 45 done, in your 55, I think it was, then in your interactive notebook done, which was Wolf reintroduction diagram and kind of explanation of what was happening there. So I'm going to come around and look for that here in a little bit. And that is that. If you're furiously working to get that done right now, just kind of save your time and don't worry about it. Just kind of would rather do something else. So, ready to make our list? So we're looking for, and I'm going to write it up here, and then we're going to go back and classify these things in a little bit. We're looking for living and non-living things that can affect other living things. So living and non-living factors that affect an ecosystem is what we're shooting for here. So I'd just like to get a great big old list. Skylar? Yes, and I didn't do that today. I will get that for you. Thank you for reminding me. Actually, no, 56 wasn't Cornell notes. Was it just like regular? Yes, don't sweat it. All right, so up here, list of living and non-living factors that can influence stuff. Start us off, Ms. Wilson. Okay, so I'm going to write I. All right, industrial development, sure thing. We'll just go around until we basically run out. Jasmine's group. Okay, can I say disease? Okay. Next group, we're looking for living and non-living.
Okay, you're not putting.
Correct.
Okay.
Next group. Time?
Yeah.
Explain that one.
It's non-living and over time things slowly change.
Interesting. That one's deep. That's like philosophical. Appreciate it. Humans, okay. Hey, Valeria. Thank you. Humans are up there for sure. Derek? Weather? Sure. Very good. We'll just make our way back around again. Emily's group. Emily, you don't have to be the spokesman. You can have Lily talk since she said like exactly 2 words this whole year. Say it again. Pollution. Sure thing. She's up to 5 with the word pollution. We're making progress. That's like a 20% increase. Next. Okay, how do we want to say that? Huh? Predator, sure thing. JJ?
What?
Explain it.
Then you don't use fossil fuels.
Okay, can we write like a bigger category like clean energy or something like that? Okay. Okay. Say it again. Okay. Natural disasters. Derek? Okay, so we'll call that like a development, like spreading, encroaching on their habitat, spreading out. Sure thing. Taylor? Thanks for making it awkward. What's that? Technology. Explain that one. Explain it. Okay, so we'll say forestry. Home with that. Okay, yeah, sure thing. A JJ. That's French for JJ. Huh?
What?
So there are a couple issues with what Gégé said. How many legs does a starfish have?
Starfish can have up to 30 legs.
Do starfish have legs?
Sorry. I use legs more often than I use tentacles.
Hopefully you do. However, I'm just giving you a hard time, Gégé. Sarah?
Well,
There's different species of starfish. He's just making stuff up.
I'm not making stuff up.
You just said, I don't know exact figures.
I don't know exact figures, but there's definitely can be a starfish with more than 21 legs.
Okay. Sarah?
This is the brittle starfish.
Okay, so let's put that, we'll call that just disasters versus natural disasters. I'm with you there. Derek? Okay, so extinction. Good one. Back around, Emily. I don't know how to spell feral. Gégé is feeling a little sarcastic today. He is a rotten human being. I got that on video. Moving our way around. JP? JP? Oh, good one. Okay. All right, making our way around. We'll put chemicals in the pollution category, I think. I'm not calling on JJ. I'll call on Leah.
What?
Sure. Yeah. Everything you've got's on there? Ashton? Rides? Explain rocks.
Like meteorite rocks? What about fire?
I like fire. We'll get one more from each group here as we go around. Derek? Valeria, you help him out a little? Out of idea. Huh? I know. Sometimes you got to carry the weight for your team. Like when your teammate shows up late to practice, and you got to play the game because they're not there. That's kind of what's happening right now. Ajay. Valeria, anything? Can you help your poor teammate out just a little bit? All right. One more from each group here. Coming around. How about we go with Lily? We'll get her up to 6 comments for the year. Very good. Jasmine? False.
Alien.
I appreciate that you're digging deep to come up with these, Skylar, but I'm not writing aliens on the board. But I appreciate your input sincerely. Yeah, from the bottom of my heart, thank you. But we're gonna.
Alienated species.
Jasmine? Sure, we can. Yeah, all right. I was thinking about it under pollution, but I think you're there. Leah? Explain.
Well, okay, so they can create isolation barriers and also.
Yeah, very good. And our last one, Sarah's got it. Why were you raising your hand then? And are there others that people just want to get up here because they need to say it with the exclusion of Gégé? Aliens are out still, Skylar. Sorry, buddy. Taylor? Yeah, actually, right?
What about hail?
That probably fits under natural disasters, though. Yes, the person who just said not 5 seconds ago that they had no more ideas, Sarah. Airplanes. Can you explain?
If they crash.
Leah?
Construction zone.
Sure, we'll call that development, like building stuff. With your ecology stuff are on page 58 in your interactive notebook. Essential question you should already have down, which is how do biotic factors affect abiotic factors and vice versa. And then topic would be biotic and abiotic factors. Ready to proceed? Spectacular. All right. Up on the board, which I know that Emily already knows and now Jasmine knows too, is a bird. And you recognize that bird. Not a parrot. It's a toucan. He's if you eat Fruit Loops or anything like that, he's the Toucan Sam. He's the bird on there. And this picture's on there because these things they've got obviously a very unique bill, and for that reason they're kind of prized. Not the bird itself, but just the bill. And they had a documentary on TV recently that documented, since it's a documentary, these birds and what's happening to them in their habitat. And that is that their beaks, their bills are prized, and as a result, people capture them, kind of like people steal the tusks off of elephants and they kill them to do that. They don't have to kill these to do this, but they cut the top part of the beak off of these things. So they cut it off. They're left with a long bottom beak and almost no top beak at all because it's like prized to have. And the documentary followed a fella, or maybe it was a group, I don't quite recall. But they went down there, they built prosthetic beaks, like top beaks for these things, to replace, they focused on one, to replace the one that they found that was missing its beak. But those things it's affecting them. It's an example of something that's affecting another living organism, that a living organism is doing, because those beaks are that way for a specific reason. Evolution's caused them to be like that. For the diet they eat, they need a beak like that. And when you take off that whole top part of it, it's a starvation type scenario. Skylar?
So wait, they don't do their top beak grow back in?
No, it's not. They don't. It'd be like cutting your nose off. It doesn't come back on. You've got to put a fake one on. JP? Thankfully. All right. So first thing we've got in this is the definition of the word ecology that I'm going to have you guys get down. And that's this. And you can shorten it. I would encourage you to shorten it into a way that makes sense for you. But it's the study of interaction, which means how things kind of fit in with each other between living things and the environment that they live in. And it tends to focus on energy transfer, as in or some of it tends to focus on energy transfer, but between one level on what we'll learn is called the trophic level, one level to the next. And within ecology, there are probably more things to do than I could ever name off. But this, like I said, you can major in this, you can get a PhD in this, you can get a master's in this, you can do whatever you want with this. And that way, have I talked to you guys about being on the plane yet? All right. So if you ever find yourself in this scenario, like you've gone through, you did ecology for an undergraduate major, so you got 4 years of ecology and you're really into it. So you go back and you spend your 3 years getting a master's degree, so now you're a master's and you want to keep going, so you spend 4 more years or 5 years getting your PhD in it. So now you're a doctor, right? So picture yourself, you're older, you're way more mature, you're better looking at this point in time, everything's going great in your life, and you're on a plane. And on the plane, there's a medical emergency, and someone says, "Is there a doctor on the plane?" And you jump up and you say, "I'm a doctor."
No, you're a science teacher.
That's true. Got her. Miss Gordon, this one's for you. And it says ASAP. So you jump up at that point in time and you proclaim, "I'm a doctor, I can help." And they say, "Great, this person's having a heart attack." And you say, "I just wanted to say I'm a doctor because I actually am. I'm not really a medical doctor, so there's not much I can do. I'm sorry." But you have that opportunity to jump up and yell, "I'm a doctor, I can help," on a plane because you are actually a doctor. What's that? No, it wouldn't. You're not lying. You're actually a doctor. And it'd be cool. They didn't ask, "Is there a doctor who knows medicine?" They said, "Is there a doctor?" And you're like, "Yeah, I'm a doctor." "I'm Dr. Wilson. How can I help?" "This man's having a heart attack." Oh, yeah, I can't help with that. Sorry. Better luck. Sorry about that.
They don't have participators on the plane.
I don't know. And maybe they do. I just don't know.
I don't know. Also, people have a hard time resuscitate them because they have enough participators.
I don't know. So what I was trying to get to with this is that within the field of ecology, there's lots of different parts you can study. The really hard jobs to get are with like big mammals. Wolves are a super hard position to get a wolf biologist. There aren't very many of those positions. There's like one in Yellowstone and then maybe a couple in other states. But big game biologists, which would be in this field, would be hard to get. Not impossible, but hard to get. Like elk biologists or wildlife biology. It's a tough one to get into. But you can do this for a career and become a doctor with this as your like emphasis. You don't make a ton of money when you work for like the state or the feds, but I mean you're comfortable. It's probably a little better than being a teacher. So you're comfortable, but you're never going to be like a 100,000-aire or a millionaire or anything like that. You'll be all right though. So that's ecology. It studies relationships between living things and other living things. In some cases between non-living things and living things, and in some cases between non-living things and non-living things. So it studies relationships between critters and their environment. And we use the word environment in here, and it's a word that gets used a bit, but it takes some definition to get here. So that's what comes up next, is a picture and the word environment. And the picture is not photoshopped. I know it looks like it probably is, but that's a real picture. So it's just not of anything local. And it looks like a levitating squirrel, but it's not. It's an actual real, these are from Canada. It's a giant squirrel, and you can see it's on a branch right there. And that's because the tree branches in Canada are much stronger than they are in the United States. It has to do with like temperature that the wood forms at as it grows. It's really complex and interesting. I'd love to get into it, but I don't have the time today. It also results in like larger animals because it's colder up there. So hence a squirrel that's about half the size of a grizzly bear. Yep. And this deer that you see here, it looks like it belongs in Africa, but it's actually native both to Africa and Canada. So it's an access deer, a gray squirrel, and a grizzly bear. Jordan? Huh? Oh, it's not. It's humongous. Yeah, that was taken with a really long lens. That's from like 2 miles away. It's very big. So, the environment that we're talking about here is made up of two factors. Really, you can distill the environment down to these two things. And that is to say that the list that we've kind of got going up there, one of those things, or one group of those things, are considered biotic factors, which are living organisms on the earth. And anything that's alive counts as biotic. Bio means life. So all living organisms that inhabit the earth are biotic factors. And just as there is like the coastal rainforest that we have here, and then if you go east a little bit, there's like the high desert region, Bend and Sisters in that area. There are different biotic factors in different regions, right? Like on the coast, if you go towards the coast over here, what kind of deer live on the coast? What kind of deer live here? Blacktail. What kind of deer live in eastern Oregon? Some whitetail, but mostly mule deer. So biotic factors are different in different areas, right? And that's true for humans too. We saw that there are humans spread out all over the globe, but depending on where their ancestors are from, they look different. If they grew up in cold climates, they're kind of short and round. If they grew up in warm climates, they're kind of tall and skinny. It just depends on where you came from. So biotic factors are living things. And then, do you know what the prefix A means? Abiotic means non-living parts of the environment. JJ, it's somewhat amusing to me, but you've got a piece of glitter right here. Missed it. Right about there. It's right on your hairline. Am I what? No, I told you had a piece of glitter. What? JJ, I think you got it, man. Everything's fine. JJ. I can't see it sparkling anymore. So abiotic factors are non-living parts of the environment. So those would be every single thing that's in the environment that's counted as not living. And we're going to go through our list up here and then maybe see if we can add to it now that we can think through this a little bit. So as we go through this list that you guys put together earlier up here, some of these things are clearly living, some are non-living, and we'll just go through these kind of quickly, like industrial development. Biotic or abiotic? That's, not living. Disease? Yeah, that's a living one, right? Like, certainly bacteria are counted as alive. Viruses are not counted as alive, believe it or not, but they still evolve and change. They're just not capable of reproduction on their own, if that makes sense. They rely on you to reproduce. Unfortunately, we don't get to talk about bacteria and viruses in here, but viruses are like the weirdest things. They are they look like a spaceship, really, like a microscopic spaceship. They get in you, and all they are is that outside skin of the spaceship, and then inside it is one piece of DNA. That's the instruction for how to make a copy of that piece of DNA in the spaceship. And it lands on your cell and injects that into your cell, and it short circuits and kind of takes over your cell. So instead of your cell doing what it's supposed to do, like make a copy of itself or produce insulin or whatever, that DNA takes it over and it just forces that cell to make copies of the spaceship and the DNA strip that goes inside of it. And the result is it just keeps going until the cell breaks. So it makes copies of that virus until the cell breaks, and then those virus particles are free to spread out after that. So viruses are really kind of weird. What about time? Yeah, not alive. Humans? Biotic. Weather? Pollution? And then clean energy would be biotic. Natural disasters? Yeah, not a living thing. Development of like housing communities and stuff like that. Yeah, kind of tricky because it's based on like humans spread, but I would still say that you're right, abiotic. Forestry practices, abiotic. Water. Okay, yeah, water's not alive. So really, we're just going through this list and saying, is it alive or not? Sunlight, not alive. Natural disasters, not alive. Extinction things. Yeah, it has to be because they're extinct, right? By definition, they're not alive. Feral animals. That's a biotic one. Overpopulation. JJ, we'll use words. Not just random like ABA. JJ, what would you like to say overpopulation? Biotic or abiotic?
It's biotic.
Yeah. Plants would be obvious then. Biotic. Fire? Not alive. War would be, yeah, probably invasive species or pesticide. Mountains. Radiation, and then mining, probably the same thing. So there's a lot of different things here. And each of these, I mean, you can imagine a way that each of these affects living things, right? And some of these affect non-living things, which can then affect living things. I mean, if we look at just a couple up here, fire is one that has dramatically changed since humans have been present in North America. There used to be like pretty low-level fires consistently, like forest fires and things like that. Native Americans used to burn giant patches of land. One reason we think they may have done that was to control poison oak, so that they didn't get poison oak as they were wandering through. And another reason was just to clear land for like animals to hunt and stuff like that. But fire used to be a pretty common occurrence, and it's actually how our forest evolved was with fire. In fact, there are trees even that exist. They produce these things that are called serotinous cones, like a pine cone, but it's an adjective to describe it, serotinous. And it means that pine cones won't actually open up until they're burned, so they rely on fire to reproduce. And without fire, those trees go extinct. They can't reproduce because there's no fire to open their cones. But fire is kind of an important one out here. And since like the Forest Service in the 1800s, there was a really big fire out by Montana that burned it killed, you ever heard of a Pulaski before? It's like an axe on one side and then like a hoe blade on the other side or whatever. And it was named after a guy who was in that like a really famous firefighter from the Forest Service back then in that fire. But since then, the policy of the government is like, fire starts, we put it out. And it causes some issues. Number one, it causes, you'd think it would like reduce fires, but it actually causes really giant fires because it builds up all the wood and stuff underneath. And then when it does start, they can't put it out because it's too intense. And then it causes problems with like habitat. Deer and elk populations aren't as numerous because they rely on burned areas to eat and graze and stuff like that. But that's an example of an abiotic factor that can affect living things. Mountains too. That seems like a weird one, but like Leah was saying, they grow and change over time, and that can cause like populations to rise or fall or become separated. Pesticide that's out there. I think we talked about bees and like colony collapse disorder, right? Did you know that bees are kind of going away? Yeah. For whatever reason, we think one reason might be pesticide or herbicide that people spray on plants, but bee populations are going down. That's a really bad deal for us because when bees get too low, that means there's no pollinators left, which means like food, all the food we eat basically relies on pollinators, right? I mean, it takes pollinators to make apples, oranges, all the fruit and vegetables you eat take pollinators, which would mean if they go away, we've got to do that by hand, which would become incredibly time-consuming. If you can picture like a cornfield in the Midwest that's like miles, and then a dude out there like pollinating with a paintbrush, going back and forth and trying to pollinate with a paintbrush. Maybe, or you can just do it with bees, and you get honey out of it too. So it's kind of, but those things are going away. So Honey Nut Cheerios tried to do a good thing, and they put like when you bought their cereal, they put flower seeds in there so that you could plant flowers and help the bees or whatever. But then all the environmental wackos went crazy because that's like they put flowers in there that are invasive in some areas. So like you'd be growing flowers that aren't supposed to be there. But like basically none of the flowers that grow here are native, like roses and tulips. They're all from Asia. They're not from around here. So they quit doing that because all the environmental weirdos got up in arms over it. So no, bees are going to die, maybe. Jordan? Yeah, that's the thing that does it.
I don't know if there's like any other way.
Yeah, and honey's kind of neat because it's got like antibacterial properties in it. It can just, like mold doesn't grow on it, bacteria don't get into it. So it's got some really neat things that go with it. But in any case, biotic and abiotic factors are what we're focusing on today. And that's kind of the short of what we're doing. It's a really short set of notes today, but that's it. Because what comes up on the next page is what I want you to do, because I want to focus in on biotic and abiotic factors because they're critical, they're important. They're what kind of control, they are what control happens inside of what's called a biome. And probably when you guys are in middle school, you studied biomes, like tundra and rainforest and things like that. These factors control what's happening inside those biomes. So what we're going to do today is kind of like a mini, whatever time is left, kind of style project here. And that is that these are the different biomes that exist on Earth. Right now we're kind of in like the temperate forest regions. If you go a little more towards the coast, like just over the mountains towards the coast, believe it or not, that's a rainforest. That's towards the coast. That's how much it rains there. It counts as a rainforest. It's not a tropical rainforest, but it is a rainforest. We've also got one that's not up here is the high desert, and that's like Bend, and over there is all high desert. But these are the different areas, some common different areas that we've got here. And what I'll have you guys do here is you're going to work in groups of 2 or 3, and that's fine with me. And this isn't going to be a poster or anything explaining, like, here's what happens in these things. All I'm looking for, as you pick one of these, and I'll come back to this slide for you, all I'm looking for is that you choose a biome that you are interested in. And if people duplicate biomes, that's just fine with me. And what I'm looking for is develop, research, come up with a comprehensive, that means like a complete list of biotic and abiotic factors within that biome. So you'd be looking at like abiotic factors that are affecting life there. So if you're in the desert, obviously you'd be talking about like water would be a pretty significant abiotic factor in the desert. The presence of it makes a big difference. If you guys have seen in the desert areas like this time of year, they have these things called super blooms, which is when water finally reaches the desert, like the 10,000 flowers that are there all bloom at one time because it's the only time they're going to get water, so the whole desert is covered by like these blooming flowers. So you're going to pick a biome and give me a comprehensive list, like a bullet-pointed list. It's going to be on the top half of your page. That lists biotic and abiotic factors, and I want them identified. Like one side could be biotic, one side could be abiotic. And what I'm really concerned about is ones that affect it. So if you're just listing like some random animals that live there, that's all right. But what I'm really concerned about on the biotic end are kind of the critical animals for that habitat, the critical animals that live there. And same thing with abiotic factors, the most important things that affect life there. On that page, on the bottom half of that page, just need a sketch that represents your biome. And it's got to include a minimum of 10 biotic and abiotic factors there. And then it says your page should also identify and explain ways in which humans are altering biotic and abiotic factors. So of the 10 that you list of each of these, I want to see under that how human activities or human influence is causing those biotic and abiotic factors to change or over time. So that's the plan. That's what we're working on. Make sense for you guys? So groups of 2 or 3. I'll put this up here so you can pick your area you want to focus on. Research is fine on the phone. I've also got the Chromebook over there if you'd like to use that. After you guys choose, I'll flip back over to the requirements page and you can take a look at that. But that's the plan for today on page 57. Sweet. There you go.